Here, I have a very small program. This program calculates the maximum pair product. I'm just going to type I am here to show the console output. Now, second line, it creates a scanner object. Scanner, and I'm providing system.in, which is my keyboard, to this object. Now, third line is creating a reference variable and assigning sc.nextInt. It just waits for the console input. Now, all this program does is ask how many numbers from the user, how many numbers it's going to calculate the maximum pairwise product. And once you have the number of products, it's going to run for that number of times and assign each array location from 1 to n a different digit which is provided by me or us. And it is going to call a maximum product, which is going to call this method. This will calculate the maximum array, maximum product, and is going to return it. It's going to print the result, and it is going to close the memory location to avoid memory leaks. And this is our method. I'm going to talk about this later. Let's run this program. It's Java application. Okay, so currently we're here in this line because this is run. I am here. Now I'm going to say that I'm going to input 5 different integers, which is 1, 2, 3, 4, and 5. So the maximum product was 20, as 5 into 4, 20. So this is what we did with our project. Now let us see side by side what happens to Java memory when I run this, the same thing. Let's just clear the input, have this, and have this. This is our Java mission control. I already told you how to download it. Now open this, make sure you have opened this. Since this is my program, so on the left side on the JVM browser, the same mbean server should be open. In my case, it is the same case. You can also check by program ID in the task manager, which is 9680 right here. Now this is using some heap memory. Here it is using how much CPU the JVM is using. And this is lifecycle fragmentation. We'll talk about this later. Now we have to focus on these two right now. All right. Now I'm going to start this, the same thing, but I'm not going to run as. Now I'm currently doing just debug as Java application. Now next thing we are going to have is a debug console on the right hand side. Currently I'm at this pointer. As you can see, I have debug current instructor pointer. When I press step over, just monitor the memory location has increased size by size because the objects are getting created in heap memory. Right. I'm going to like 5 here. This gets increasing. Step over. 1, 2, 3, 4, 5. This gets increasing little by little. Now next. Sorry. Is this a loop? All right. We have already seen that one garbage collector is called by Java. The maximum memory it used was 222 MIB. So now the current pointer is here. Let's do step over and see how it affects our memory. You can also see the CPU usage after each and every line. All right, I'm going to close this. Our result is printed. This is 20. This is 5 into 4. All right, now I'm going to end this thing. As soon as this is ended, all this memory, 170 MB, some of those is garbage values, and Java will collect it. We don't have to do anything with it. It will only collect when it thinks that it needs to be collected. Now I'm going to run the same program, but with a different tweak. I'm going to remove all this debug point. I'm going to have this debug point all over here only. So I'm going to debug as Java application once more. I am here 5, 1, 2, 3, 4, and 5. Now we are here at system result. Now slowly, before doing this, let me restart this once again. 5, 1, 2, 3, 4, and 5. Now we are again here, but this time when we exit our main method, before we exit our main method, we will call system.gc. This is a method of Java collection. If we go into the source code, let's see if it's available. Yes, it is available. So it will going to do a garbage collection on one time. Let's just read this on this. Runs the garbage collector in the Java virtual machine. Calling the GC method processes the Java machine expend effort towards recycling unused object in order to make the memory currently occupied available for reuse by JVM. So this basically tells the JVM to do a garbage collection manually. Let's do that. Now current pointer is here. As soon as I close this, the Java collection appeared. The same can be seen here. Okay, that's it for now. You can do any method you want. You can run this JVM when you run any program, even if you run the Hello World program, it's going to work anyway. So this is how to monitor your Java application on runtime.